Many people think science and art are very different, but not so. Science is about taking the time to look and to think like you might with a painting, seeing the patterns and building the hypothesis. This is where the art of science comes in. Esto es Real Chem. The periodic table is amazingly powerful because it can project, not just document, the behaviors of the building blocks we use to assemble matter. That is why I always have a periodic table in my pocket. The periodic table helps us generate hypotheses. Like, if silicon is a semiconductor we can use to build computer chips, maybe germanium, which is right below it in the periodic table, can be used to build even better computer chips. Exploremos. When Dmitri Mendeleev came up with his periodic table in 1870, he knew he was onto something. The patterns it revealed in the properties of the elements were very compelling. But there were also some gaps in his table that could not be filled with any known element. Rather than view this as a potential flaw, he used these gaps to put forward a bold hypothesis that the gaps will someday be filled by yet undiscovered elements. In addition to hypothesizing the existence of these elements, he used the periodic trends to estimate their density, physical appearance, reactivity, and other properties. A few years later, gallium was discovered, confirming his hypothesis by filling one of the gaps on his table and showing that his predicted properties were actually pretty close to reality. Funnily enough, the person who discovered gallium measured those properties incorrectly. Mendeleev proved him wrong without ever seeing gallium. This was an early example of the use of periodic trends to form hypotheses, a trend that continues to this day. Periodic trends include the tendency of elements in the same column or group to behave similarly. Let's take a brief tour of the periodic table. From left to right, we start with group 1 metals, alkali metals, a family of soft, shiny, and fiercely reactive metals. They have one lone outer electron in their outermost energy level and low ionization energy. Hence, their need to find stability driving their potent reactivity. Group 2 metals, the alkaline earth metals, come next. These are also reactive, although not as violently as group 1, as they have 2 valence electrons. Not quite as easy as it is for the alkali metals to do a deal. The nice rectangular block in the middle of the periodic table holds the transition metals. Those we are mostly familiar with. It includes gold, iron, and titanium. They have a variety of electron configurations and partially filled soft shells, giving them rise to their ability to form diverse compounds. The majority of the elements are metals. Between them and the nonmetals containing carbon, nitrogen, and oxygen, the elements responsible for the formation of living things. We then have metalloids. These play an important role in semiconductors used in electronics. Almost, but not quite full to the right side, we have the nonmetal group 7 halogens. These elements are called salt makers for their ability to stabilize the reactive groups 1 and 2 elements to form stable compounds like, well, salt, sodium chloride. Lastly, the final group on the right, the noble gases. Too noble to sit with the rest of the elements. These nonmetal elements are unreactive. They have field valence electron shells, rendering them inert, simply because it is very hard for anything to bond with them. Although unreactive, they still have applications in the modern world, including neon lighting, high-beam headlights, and helium party balloons. Testing hypotheses is an essential aspect of the practice of science. But the art of science lies in generating hypotheses that are worthy of testing, looking for patterns in what is known. Aquí es donde la ciencia se convierte en arte. And there are few patterns more beautiful than those in the periodic table. I just love the periodic table. So let's explore and remember to have fun. Exploremos y divertámonos.